I'm Morgan, and I'm going to be talking about how web designers or anyone who designs for the 2D space can start designing for 3D, with a specific emphasis on AR and VR. So to start, who even am I talking to you today? I work at Mapbox. We do maps, like anything to do with maps, we do it. And that's where I'm an AR engineer. My job is basically to figure out what AR is good for. I'll let you know when I find out. Before that, I used to work as a web designer and developer. So I think that's a maybe pretty similar background to a lot of you here in this room, which is just to highlight that any of you can also get started in this space. In my free time, such that it is, I like to make little small video games, and I have made my own VR experience before through an incubator program in San Francisco. So it's a little mixed bag of experience, because there really is no traditional path into this stuff because it's so new. So why should you even learn 3D design? I would say that it's a ton of fun, and that's a good enough reason to do anything. But you have to make money. So the next best reason to do it is that it really will look good on your resume, or LinkedIn, or whatever you use. If I see someone who knows how to do 3D modeling, or has designed for VR before, or gosh, there's so many skills you could learn in this space, but if you have any of that, you really will stand out compared to other designers, and it will open new doors. More and more companies like Apple, Google, Facebook, and smaller companies like Mapbox are investing in this space. It's a very hot topic right now in Silicon Valley. But those 2 points aside, I'd also say it's really one of the nicest communities of developers and designers I've ever encountered. Because it's such a new field, it's very diverse still, it's very inclusive, people are just creative and playing around, and no one's a rock star or a guru yet, and that alone makes it really pleasant to work in this space. So a question I get a lot, and this is a really valid question, is what actually is the difference between AR and VR? I actually like the idea of whether or not you've given up on the world. That's one way to determine the difference. But I'd say that AR basically shows you the real world with a digital overlay. So for example, here's something we worked on at Mapbox, where someone's looking through their phone, they see the desk, they see the room, but they also see a digital city. Most famous example of this is Pokemon Go, if any of you have ever played that, where you can still see the world outside, and you can also see the cute little Pikachu. So that's how your reality is augmented. No one really knows what the killer app is for AR, though, and a lot of the media you'll see around it is completely fake. Like, this is Google Glass. I can guarantee that it did not look like this. This is not a real app. So people are still trying to figure out, what's the point of this stuff? What can we do with it? What's going to make us a lot of money or, be substantive? I have my own ideas on that. I think that world-scale AR, which is basically AR that shows you information about the real world around you, is going to be one of the most helpful things. And that's something I've explored as well in my own work. So this is the Embarcadero in San Francisco, and I know that Joshua Tree, a park in California, is in that direction. And this is kind of a goofy example, but you could see how if you just want to find your way around Stockholm, for example, and want to find the best bakery here, you could have an app that's like, okay, turn here at this street, or it's right next to this other store. But you don't have to stick to the real world at all. You can also, go into D&D and show real monsters from the monster manual virtually. And that, again, that's just a silly example, but there's a lot of options here. The key takeaway, though, is that you can see what's around you, but you also see something else. But as you can see here, like, no one else here can actually see what this woman is looking at. So that's something to take into consideration. VR, however, is a 100% completely digital world. You don't see the real world at all. This is often the stereotype that comes up. It is pretty accurate, though. You're going to have a big, bulky headset that blocks everything out, and you're just going to look in complete awe of whatever you're looking at. Again, there's 2 types of VR here. There's room scale, which means, I could walk around in a space not really that much bigger than this stage, and that experience is confined there. Or like Google Cardboard, I actually can't walk around at all. I can just move my head and look, but if I start walking, this app has no idea that I'm doing that. It doesn't know where I am in space. Either way, though, again, the main takeaway is that you have to recreate a digital world entirely. You don't rely on any information from the real world, and people will not be able to see the real world. So they might walk into walls or trip over something. That's a real consideration for VR design. And I know there's usually a ton of other questions that go along with this. People think, you need thousands of dollars for the best software or the best custom-made computer. You're going to have to do math. Maybe it's too late to get started in this space. It's not. You don't need any of that at all. Whatever experience you have today and right now, it's enough to get started. So if you actually do want to go home later and start playing around with 3D, there's a lot of different software you could get, but I'll just give you a few recommendations. For 3D modeling, which is kind of what it sounds like, but it's making the 3D assets themselves. So like the little Pikachu you saw earlier, the person who made that probably used one of these tools. You can use any of them. Blender is free, Maya is free if you pretend you're a student, Cinema 4D Lite comes for free with After Effects, which a lot of you may have. I would say just try any of them that you have access to and see what makes the most sense to you. Really, if you're trying to get a job in this space, no one cares which tool you use because they're all pretty similar. So if you understand the concepts in one, you'll understand it in the other. If you actually want to build things and not just do 3D modeling, I'd say the best piece of software you can get, and this one luckily is free and you don't have to lie about your status as a student, is Unity. And that's a game engine. So you can just use it to make games, and that's a ton of fun too, but it will support AR and VR applications. So for example, if you want to make stuff in AR, Apple has ARKit, which is their little AR library that does a lot of the computer vision, math, and all of that for you. Likewise, Google has Cardboard, which handles like how you have two cameras basically that kind of simulate the eyes. And long story short, you don't have to do the physics and all of that yourself. Again, there are absolutely other platforms, other tools you can use out there, and I at least felt pretty intimidated when I first encountered all this stuff because I didn't know which one was the correct one. Good news, there is no correct one because we don't know what we're doing. And I would say the last thing you need that's actually the most important is a curiosity and a creative spirit and willingness to try things that haven't been done before. You might not even be sure that they can be done. Like, I don't know if anyone watches King of the Hill. It's a very American show, but this really sums it up. I'm skeptical that you could, yet intrigued that you may. So now for kind of the meat of all of this is how is designing for AR and VR even different than designing for websites or mobile apps or whatever it is that you're all designing? I would say, again, 3 big differences. There are no rules, there's new interactions, and there's more math. I know I just said a few times that you didn't have to do any math. I kind of lied. If you want to do, let's say, really custom graphics or really custom animations, or that world scale AR stuff I was talking about, where I know that a national park is in that direction, that involves some math. You're going to have to think about trigonometry and matrices and linear algebra, all of which I was terrible at in school. So again, don't let that stop you. But for the most part, people have already figured this stuff out. Even if it's not built into a platform or anything, someone else has for sure written a Medium article with how they define their function, and you can go ahead and copy and paste that in, and no one will ever know. So there might be math, you don't have to do it. And I did say there are no rules. There are like some rules. But these are more guidelines at this point. So for example, Oculus, their introduction to best practices for VR is a really, really helpful source if you want to design for VR and start thinking about what are the specific limitations, what are some of the challenges. But again, all these rules are meant to be broken. Google has written similar things about AR, and shameless plug, so have I. And there are people who are starting to think about, okay, for example, with VR, it was common knowledge that, let's say you're in a VR experience like Google Cardboard where it doesn't track where you're moving, and then you start moving. That means that there's a mismatch between what your body's doing. Like if I'm stepping forward, the app doesn't know that, so it thinks I'm sitting still. That's what causes you to be sick in VR. Your body actually thinks you've been poisoned because it's getting two different responses, and it's just like, time to throw up, I don't know what else to do. But people have actually discovered that you can get around this. There's a VR app called Eagle Flight VR that's really, really awesome. You basically play as an eagle flying over post-apocalyptic Paris. And so you're just sitting there, not moving, but in the app you are flying through Paris, and it's really beautiful and soothing. The way they got around this is pretty ingenious. They gave you a digital beak because you don't think about it, but you do always see your nose in front of you. And that's somehow enough to ground you and to understand what's happening. So having a virtual beak doesn't make you sick anymore. And that's just one specific example, but the real takeaway is that whatever you read, if anyone ever says, don't do this, or definitely do this, or that's impossible, take it with a huge grain of salt. We don't really know that for sure yet. The new interactions, I would say, are the best part. So one of the most common ones, because this one can apply to any app and experience whatsoever, is raycasting. So this is a Google Cardboard headset. All you can really do is look through it and then maybe tap that button, but not every headset has that button. So all you're really allowed to do is face something. And that can actually be enough to trigger an interaction. So in this case, this person might be looking at that particular bottle for enough time, and usually there's a little timer that comes on. And so if you look at it, let's say for 3 seconds, so we assume you've been pretty intentional about looking at it, then something will happen. And again, it's not as flexible or robust. You don't have a keyboard, you don't have a mouse, you don't have all this interaction available to you. All you can do is face something, but that is enough to get started. And the VR experience I built was done entirely with this form of interaction. A next step up is having that plus a controller. So this is the Magic Leap, which just came out a few weeks ago. So he's looking through an AR headset, and he's holding a controller. It's kind of similar to a video game controller. So if you take half an Xbox controller, that's about what you get. And that does open up a few more doors, but you only have like 4 buttons on that thing. So again, you're limited to, okay, maybe I have 2 to 4 buttons to work with. I can do things. How do I map all these interactions to just those few things? Plus him looking at something, you're still limited. So for example, if you want to make something like a keyboard, you can't really do a keyboard with just a 4-button controller and the ability to look at something. Or maybe you can. Someone please prove me wrong about that. One really cute and creative solution that I've seen is from Normal VR, and they created a VR keyboard that works as a xylophone. So you have your 2 VR controllers, and you see the keyboard in front of you, and you just kind of like tap on it. And I think that's adorable for starters, but it's a really good way of using the limitations of these really few controllers that you have to work for you. One of the challenges that I'm specifically looking at too is, especially with world scale AR, but also room scale VR where you can walk around, is okay, now let's say we know where people are looking, they have a controller. Where is their body in space right now? So if you think about the websites some of you may have designed, have you ever had to think about whether someone was standing or sitting up, or whether they were moving if they're using your mobile app? Maybe some of you had, but I bet that doesn't really come up in the design reviews. It absolutely will with AR and VR, especially AR. So one of the examples that we've been working on are these world-scale AR directions, like I was talking about. So okay, I go this way down the street, and then I cross the street, and I go wherever. But that means that the app has to know your exact geolocation, so your coordinates in the world, be very, very accurate. It has to know when you start moving. It has to know when you're not moving. VR doesn't really look into your coordinates, like where you are in the world, because again, you're not interacting with the real world. But for example, if I'm in a room scale VR experience, there might be something over there that I have to walk to. And it might know if I'm getting closer or if I'm not. I've also seen some VR games that take into consideration your own height. And let's say I start here, maybe it needs me to do something down there, and it'll only get triggered once it detects that the headset is low enough. So you can encourage this kind of movement, or discourage it, or do whatever you want with it, but it is a real factor in your designs. And all that is really exciting, but it is really challenging. So I'd say one of the biggest challenges is that you're not in control of your experience anymore. The user is. Especially with AR, but really with both experiences, they 100% control the camera. So I know in web design we talk a lot about, let's say, the happy path, or there's certain ways to design navigation where you're like, well, people usually look in the top left corner, they don't really look in the bottom right corner. We'll design things for that. As soon as people start an AR or VR experience, they try to break it immediately. They will look behind things. They'll look under your models. They'll walk around to the edge of an experience. If they can pick things up and throw them, they 100% will every single time, because it's a lot of fun. You can be messy without making a mess. So in this case, for example, we made a real-time cloud cover visualization of San Francisco. If you've ever been there, you'll know that there's a lot of fog and a lot of clouds, and about half, like usually, the fog is exactly in the western half of the city, just because of how the geography is. That day, it was everywhere. It's very cloudy in the summers, but you can see, okay, this is what the cloud cover is. I have my little model. I could put that in AR, but you could look under it. There's nothing stopping you, and there's nothing interesting to do there, but people will look under it. So that means that when you're, let's say, designing your 3D models, or you're laying out a VR scene, or you have an AR experience, you're like, okay, I want them to see a map, or I want them to see Pikachu. You can design for the happy path all you want. I don't think anyone's ever going to take it. So you have to consider, okay, what does the bottom of this thing look like? What does the back of it look like? What happens if someone goes out of bounds, or if they look somewhere else? Audio is a really, really useful thing as well. So some VR experiences will start with wherever you're looking. Most of what you have to play with and work with is within your field of view, which is actually quite narrow. If you want someone to turn around, you might have to use audio to indicate, hey, there's something behind you, because they just might not ever look there. Or they might immediately look there, and then they'll never actually look at whatever was important. So I would say with VR, if that's really the area that you want to get into, you can think of it a lot more as set design. So how does lighting and contrast and composition come into play, and what does it encourage people to do? And that's really not too different from web design. Of course, we all think about similar ideas, but I think in VR it's a little bit more literal. With AR, you just don't know where someone's going to put the digital experience. You don't know if it's going to be on a table, if they're going to be walking when they're doing it. You just don't know what's going to happen. And another one, and I kind of alluded to this, is that people's height and ability really matters. So for example, I was talking about the VR experience where you start down here, like up here, maybe they need you to crouch down, and once it knows that the headset is there, it'll do something. That's still assuming, though, that someone can crouch down, and that whatever you think of as being standing and whatever you think of as being crouched applies to everyone. It doesn't. So if a child wants to use a VR experience, and I don't know, children are small, that's like maybe here, and an NBA basketball player wants to use your VR experience, and they're like up here, they're going to see the VR world very, very differently. And of course, if someone is in a wheelchair, or if someone is just sitting down or not standing up, that's going to be a different experience. So one of the things that I was working on, as I mentioned earlier, was showing where national parks are compared to you. So for the 2D experience, you might have, okay, here I am, and here's some national parks, and that's cool, I can see it all at once. It's really nothing to do with my body or ability. But I did want to show this in AR with a pretty accurate horizon line. So that's where a lot of the math came in. And really, thank goodness for Wikipedia. I did not figure out the math myself. But it knows, based off your altitude, which might just be your height, plus your elevation, what does the horizon look like to you? And honestly, for a lot of people, it'll look pretty similar. But you can imagine how for a child or a basketball player, the horizon will look different. They're not going to see the same thing. So this is another example of having to take that into consideration. And I know all of that kind of sounds like a lot, because it is. And it's all very new, but we're all figuring this out as we go. And you don't have to have all the answers right away. Because if there's anything you take away from this talk at all, it's that no one has the answers about AR and VR. So in a way, I kind of lied to you again when I said this talk would be learning how to design for those things, because no one has the definitive answers. But I can tell you what to think about. You have to think about people's bodies and their abilities. You have to think about what they're doing in space and how that makes them feel and what the interaction might be when you're not in control of things. You have to be okay not being in control of things. And you should really download Unity. This isn't a plug, like a promotion for Unity, but it's amazing. And earlier, before we wrap up, I had mentioned that the community is really awesome, and I really do mean that. And I would say if you are interested in this space, if you want to see more examples of what people are doing that's really exciting, if you just want to meet more people in this space, I'd say there are 3 people that should be on your radar that you may not have heard about before. The first is Cuervo. He is an AR prototyper, actually like myself, in San Francisco. He works with both AR and VR, especially web VR, so this is stuff that works in the browser, much more accessible to a lot of people. And he just makes really cool stuff. I'm always in awe of what he's working with, and it's very creative and artistic, and just these goofy little experiences. And seeing stuff like that is really inspirational. The next person is Ghost Meat, aka Claudia. She also works in AR and VR, but focuses more on VR and making these really soft, meditative experiences in VR that also do rely on what your movement is. So she made an experience in the same incubator program I was in that knows when you're standing up and knows when you're lying down. And when you're lying down, just looking at the sky in her VR experience, it'll start to change. So really looking at how this technology can be very soft and beautiful. And last but not least is Devin, aka 3D for Designers. Some of you may have already heard of her or seen her work. She has actually put together a class for Cinema 4D, so any of you who are interested in learning that, I really can't recommend this class enough. But in general, she shares a lot of 3D modeling work. So if you're maybe kind of ambiguous about whether you want to get into AR, VR, or a different platform, but you know that you want to do the 3D modeling, I would really recommend looking into her work and the kind of people and artists that she shares, and take her class. It's a lot of fun. So thank you so much.